Good morning. I am Navya. Our PBL topic is Vehicle Accident Control, and our group members are Lata KM, Neha Rao, Nikita VS, and RM Shubha. Problem statement. Here, many accidents happen because driver feel sleepy while driving. When a driver is not full alert, they cannot properly control the vehicle, which increase the risk of accident. The main objective of the system is to detect driver sleepiness at an early stage. When the system identifies that the driver is feeling sleepy, it immediately gives an alarm alert to wake up the driver. This helps the driver regain attention and prevents accidents, thereby saving their lives. System architecture. The vehicle accident control using sleep alarm system works as follows. First is supply. It provides the required electrical power to the components of the system. Second is eye blink sensor. It continuously monitors the driver's eye movements. If the driver eye remains closed for a long time than normal, it indicates drowsiness. Third is microcontroller. Here we have used Arduino. It act as the brain of the system. It receives data from the eye blink sensor and process it to determine whether the driver is sleepy or not. Fourth is alarm or buzzer. When the microcontroller detects drowsiness, it activates the alarm or buzzer. Fifth is driver alert. The alarm sound alert the driver, helping them wake and stay focused on driving. Thank you.
I am Lata. Components, hardware and software. Arduino Uno is the main controller of the system. It receives input from the eye blink sensor, processes the data, and controls the alarm when drowsiness is detected. Eye blink sensor. Eye blink sensor is used to detect whether the driver's eyes are open or closed. Alarm. Alarm buzzer. The alarm gives the sound alert when sleep is detected. This alert helps to wake up the driver and prevent accident. Power supply. The power supply provides required electrical power to Arduino and sensor and alarm so that the system works continuously. Arduino IDE software. Arduino IDE is the software used to write, compile, and upload the program into the Arduino Uno. It contains the logic for eye blink detection and alarm activation.
Sensor data acquisition. This means collecting information from sensor used in the system. Sensor used. The eye blink sensor is used to detect driver sleepiness. The eye blink sensor checks whether the driver's eyes are open or closed to find out if the driver is feeling sleepy. Type of data. The sensor gives data eye open or eye closed. The sensor sends simple information like eye open is equal to alert and eye closed is equal to sleepy. Data collection. The sensor continuously monitors the driver's eye movement. This sensor keeps checking the driver's eye all the time, not just once. Data transfer. The sensor data is directly sent to the Arduino Uno microcontroller. The iBlink sensor sends its data to the Arduino Uno, which controls the system. Purpose of data. The data helps the system decide when to activate the alarm. If the driver's eye stay closed for too long, the system uses this data to turn on an alarm and wake the driver. Data pre-processing. This means cleaning and preparing the sensor data before using it. The system first checks whether the sensor data is correct and usable. The system checks if the data coming from the sensor is proper and valid and not wrong. Wrong or empty data values are ignored to avoid false alarms. If the sensor sends wrong data or no data, the system does not use it so that alarm do not turn on by mistake. Small noise or unwanted signals from the sensors are removed. Tiny disturbances or extra unwanted signals from the sensor are removed to keep the data clean. The data is converted into simple form the microcontroller can understand. The sensor data is changed into a simple format so microcontroller can easily read it. The processed data is sent for the further decision making. After cleaning and simplifying, the data is sent to the system to decide actions like on an alarm.
Good morning, I am Nikita BS. Next, I am going to explain the data structuring and cleaning. Sensor data is collected in a numerical form. Sensors like temperature, humidity, pressure sensors collect data as numbers. Numerical data is easy for computers and microcontrollers to read and process. For example, temperature is 25 degrees Celsius and humidity is 60 degree. And second one is wrong or incomplete data is removed. Sometimes sensors give incorrect values due to errors, noise, and faults. Incomplete data can cause problems during processing. Such data is removed so the system works correctly. Example, a temperature value of minus 99 or no value at all this discarded. And third one is repeated or unnecessary data is cleaned. Sensors may send the same value repeatedly without change. And unnecessary duplicate data increases memory usage and slows processing. Cleaning removes repeated data to keep only useful information. And fourth one is clean data is arranged properly. After cleaning, data is organized in a clear format. Proper arrangement makes it easy for the Arduino to process. Data may be stored in arrays, tables, or fixed order. For example, sensor ID to time, time to value. Fifth one is processed data is stored temporarily in memory, and cleaned and structured data is stored in the microcontroller's memory. Storage is temporary because Arduino has limited memory. The data is used for collections, calculations, decision, or display. For example, turning on a fan if temperature exceeds a set limit. And next slide is communication protocol. Series communication protocol is used. A communication protocol is a set of rules that decides how data is sent and received. Serial communication sends data one bit at a time over a single wire. Arduino commonly uses several communication because it is simple and efficient. Second one is allows data transfer between sensor and Arduino. Sensor collect data from environment like temperature, gas, motions, etc. This data sends to be sent to Arduino for processing. Serial communication makes it easy for the sensor and Arduino to talk to each other. A temperature sensor sends data values to the Arduino. Data is sent in simple digital signals. Data is transmitted as digital signals like um, 0 and 1 bit. A digital signal reduces errors and are easy for microcontrollers to understand. This makes communication more accurate and stable. And fourth one is communication is fast and reliable. Serial communication provides quick data transfer. It ensures data reaches Arduino without loss or confusions. Renewable communication is important for real-time systems. And fifth one is helps in quick activation of alarm system. When Arduino keeps critical data like high temperature or gas leakage, it can immediately activate an alarm or buzzer. Fast communication helps in quick response to dangerous conditions. Example, gas sensor detects leakage and data is sent to the microcontroller and alarm turns on. Thank you.
My name is Shubha. I am explaining data flow evolution. The sensor sends data to the Arduino very fast without any delay. When driver sleepiness is detected, the system responds immediately. The data transfer works continuously and reliably without errors. Once drowsiness is identified, the alarm turns on instantly. Overall, the system runs smoothly and remains stable during operations. Next slide is summary of review 2. Sensors and microcontroller are successfully set up to detect driver drowsiness. The alarm system is properly connected and tested with the controller. Sensor data is being collected and monitored tightly. Arduino software processes the data and triggers alerts when needed. The system is working well and is ready for further testing and improvements. Thank you. Now I am explaining review 3. Recap of review 2. Sensors collect data to check whether the driver is feeling sleepy. Second one is Arduino Uno processes the sensor data and the noise is removed from the collected data to get accurate result. Clean data is stored temporarily in the system memory and next the controller quickly transfers data and activates the alarm when needed. Overall, the system works fast and reliably to prevent accidents. Next slide is result interpretation. Sensor data is analyzed to detect driver sleepiness and drafts shows changes in eye blink or alertness level. Sudden changes in the draft indicate driver drowsiness. Alarm activation in the draft shows the system is working correctly. The results prove that the system can detect sleepiness early.
I am Lata. System output. Output when driver is sleepy, the system generates an output as soon as it detects that the driver is feeling drowsy or sleepy. Clear display of sensor readings, a real time sensor value, and alert messages so the system's working can be easily understood. Driver status on dashboard. The dashboard clearly indicate whether the driver is alert or drowsy. Alarm status indication. The alarm output is shown as on when drowsiness is detected or off when the driver is alert. System verification. The results confirm that the system works correctly to alert the driver.
Performance assessment. This explains how efficiently and correctly the system works in real solutions. System response time is very fast. The system does not take much time to react after receiving sensor data. This helps in quickly identifying driver sleepiness and preventing accidents. Alarm activities immediately when the sleep is detected. When the system detects that the driver's eyes are closed for too long, the alarm starts without delay to alert and wake up the driver. System works reliably without frequent errors. The system gives correct results repeatedly. It does not stop working suddenly or give long alarms often. Power consumption is low and efficient. The system needs very little electrical power to run. This makes it suitable for long term use in vehicles. Overall, the performance is stable and effective. All parts of the system work together smoothly. The system performs its main task properly and consistently.
BS challenges faced. Sensor did not detect the driver properly. Sometimes the sensor failed to correctly sense the driver's conditions. This could happen due to wrong sensor placement, poor sensitivity, or external troubleness. Small error in microcontroller programming. The code written for the microcontroller had minor mistakes. These errors caused incorrect working of the system. Debugging and correcting the code took extra time and effort. Third one is alarm triggered at the wrong time. The alarm sometimes turned on even when it is not needed. This happened due to false sensor reading or incorrect threshold values. It reduced the reliability of the system. Fourth one is difficulty in collecting accurate sleep data. Measuring the driver's sleep or drowsiness level accurately is challenging. Human behavior varies, making data collection inconsistent. This affected the accuracy of sleep or detection. And fifth one is poor supply or wiring issues. Loose wires or unstable power supply caused irritations. These hardware problems delayed testing and troubleshooting, and proper connections and stable power were required for smooth operations. Thank you.
I am Navya. System reflection and improvements. First one is system works well but may not detect sleep in all situations. The system is effective in identifying driver drowsiness using sensors like eye blink sensor. However, in some situations like poor lighting, unusual driver posture, or sensor abstraction, it may not correctly detect sleep. Second one is false alarm due to sensor inaccuracy. Sometimes the sensor may trigger an alarm even when the driver is alert. This can happen if sensors are not properly fixed. Sudden head movement is mistakenly taken for sleep. External disturbance affects sensor readings. Third one, improvement with better sensor and faster processing. The system performance can be enhanced by using uh, high quality sensors, for example, camera based, etc. Using fast microcontrollers or processors. Next is applying better or algorithms to filter noise. Fourth point is future version with mobile alerts or automatic vehicle control. Sending alerts to a mobile phone or smartwatch. Automatic speed reduction. Land control or engine cutoff in extreme cases. Fifth is overall impact on accident reduction. Even with limitations, the system significantly helps in reducing accident caused by driver fatigue. Uh, Adding advanced features can make it smarter, safer, and more useful for long distance drivers. Conclusion. The system effectively detects signs of driver drowsiness by continuously monitoring driver behavior. This proves that the concept of implementation are successful. Once sleepiness is detected, the system immediately activates an alarm. These timely alerts help the driver regain alertness, thereby reducing the risk of the accident. The main objective of the project is driver safety and accident prevention are fulfilled. The system addresses one of the major causes of road accidents, for example, driver fatigue, etc. The system responds quickly when drowsiness is detected, showing, showing the driver performance. Fast response time is crucial in real time safety systems. Overall, the system is increases driver awareness and promotes safer driving habits. It contributes posi- positively to road safety, especially for night drivers and long journeys. Thank you.
Now I am going to explain the code, explain what the project is about. It uses eye blink sensor, Arduino Uno, and an active low relay to stop the vehicle if the driver sleeps. IR sensor is connected to the pin 2 of the Arduino Uno board. Relay pin is connected to pin 7. Buzzer pin is connected to pin 8. Wired setup. This function runs only when the Arduino starts. Pin mode IR sensor, input. This sets the IR sensor pin as input to read I status. Pin mode relay pin, output. Sets the relay pin as output to control motor on or off. Pin mode buzzer pin, output. Sets the buzzer pin as output to turn on sound on or off. Digital write relay pin, low. Relay pin is active low, so low means motor is on. Digital write buzzer pin, low. This means low turns the buzzer off. Serial dot begin 9600 starts the serial communication to message show message on serial monitor. Void loop. This function runs again and again continuously. Int IR value is equal to digital read IR sensor. Reads the sensor value. Low is equal to I closed. High is equal to I open. If IR value is equal to low, the sensor reads low. It means I is closed. High turns the relay off. Motor stops. High turns the buzzer on to alert the driver.
Components Arduino Uno. It is the main controller of the system, executes the program and controls the connected components. How it connected? Power using USB cable from a laptop. Digital pins are connected to relay module and sensor module. Breadboard. Why it is used for a temporary connections without soldering. Helps in easy testing and modification of circuits. Arduino are connected to breadboard power relays. Sensor and modules take power from these relays, and DC motor with wheel converts electrical energy into mechanical energy used to move the robot or mechanical systems. Motors terminates all connected to relay output. Battery supplies power to a motor. Relay module acts as an electrical switch, allows Arduino to control high power devices like motors. Input sides VCC is equal to Arduino 5V, and output side is connected between the battery and motor. Battery package provides external power for the motor, and Arduino alone cannot supply enough current to run the motor. Positive terminal is connected to the relay common terminal, and negative terminal is connected to a motor negative terminal. 9Y battery can be used as an additional power supply for sensors or control circuits. Connected to breadboard or module through a battery chip. IR sensor detects and surface color and sends signal to Arduino for decision making. Jumper wires used to make connections between components, easy to plug and remove, connects Arduino pins to breadboard, relay and sensor and motor. USB cable supplies power to Arduino used to upload the power program from computer. One end to Arduino USB port. Baseboard holds all components firmly and provides mechanical support. Working of vehicle accident control. The code is dumped to the Arduino Uno board, and it is connected to a working module through a USB code. And the working of accident vehicle control, when the driver sleep drowsiness, the alert message is sent to a driver, and vehicle stops. And then when the driver's eye is open, then the alert message is cancelled, and vehicle started moving.